In this presentation, we will cover the general aspects of nonlinear curve with least square regression fit. We will mainly address the quadratic model, which is a polynomial of the second degree. Linear curve is the first-order polynomial. A definition of polynomial is that a polynomial is an algebraic expression that consists of a sum of terms. There are other higher polynomial models and also other curve fits available. They are beyond the scope of this presentation. If you would like to learn more on those topics, please refer to NIST website section 4.8.1.1. NIST defines a nonlinear regression model as any model of the basic form in which the functional part of the model is not linear with respect to the unknown parameters, and the method of least squares is used to estimate the values of the unknown parameters. Method 8000C states that historically, many analytical methods have relied on linear models where the instrument response is directly proportional to the amount of a target compound. With the development of new detection techniques, all the analytes of interest cannot be optimized using a single model. The analyst will thus face situations where the linear model will not be appropriate. 8000C has also inserted the following cautionary note that a nonlinear calibration model may be employed if the following steps have not resulted in an acceptable linear curve. 1. Changing instrument operating parameters. 2. Reanalyzing the problematic calibration standard. 3. Narrowing the calibration range by dropping or replacing end standards. And if 4, the analyst knows that the instrument response does not follow a linear model over a sufficiently wide working range. A note of caution is placed in 8000C concerning the use of nonlinear calibrations. A nonlinear model should not be used to compensate for detector saturation or to avoid proper instrument maintenance. The nonlinear calibration should not be employed for analytes if they have shown to be linear in the past using a particular instrument or method. According to 8000C, additional criteria that needs to be met for a nonlinear curve are: 1. A curve must be continuous. A curve is considered continuous when it has no breaks in the function and has consecutive numerical values along the function, whether increasing or decreasing. 2. The model must also be continuously differentiable and monotonic, such that it results in a unique number for the unknown. The coefficients that describe correlation for a nonlinear curve is called the coefficient of determination, COD, R-square, and it measures the goodness of fit. COD must be greater than or equal to 0.99 to be acceptable. When the COD is equal to 1.00, it represents the best curve. This slide shows the basic formula for a quadratic equation. These are the equations to solve for coefficients A, B, and C. The equations continue in the above and the next slide. The analyst is now able to solve for the coefficient of determination, R-square. These are the keys for the previous equations. These equations are for solving concentrations. According to NIST, the biggest advantage of nonlinear least squares regression over many other techniques is the broad range of functions that can be fit. NIST lists the following disadvantages. 1. The presence of one or two outliers in the data can seriously affect the results. 2. There are fewer validation tools for the detection of outliers than there are for linear regression.